All right, let's talk about some new formulas now that are very related to the compound angle formulas, and these are the double angle formulas. These essentially are just a special version of the compound angle formula where both angles are the same and then they're just being added together. So we write them as cosine of 2a and sine of 2a. It's really easy to derive the double angle formulas just using our compound angle formulas. I'm just going to walk you through it. This is not something that you need to memorize per se, you just have to know how to use them. So if we have cosine of 2a, or perhaps to make it clear, I'll write cosine of a plus a. Well, our cosine angle compound formula would then turn this into cosine of a minus sine of a sine of a. What's happening here is we have cosine of a being multiplied by itself, and so we can just write cosine of a squared, and then the same for the sine of a. The whole thing is squared. And in trig, the way that looks, another way of writing that would be cosine squared of a minus sine squared of a. So this is your cosine double angle formula. Pretty straightforward, eh? We can follow the same thought process for our sine double angle formula. What that's going to end up being is sine of a cos of a plus sine of a cos of a. This is just two of these, and so we can simplify this to 2 sine a cos a. That is our sine double angle formula. So if you ever forget these, you can just derive them because you will have the compound angle formulas memorized. Pretty straightforward. Okay, I do have them written on the top of our second sheet here. How convenient. Okay, another thing to remember that hopefully you are familiar with from last year is that cosine squared of theta plus sine squared of theta is equal to 1. And we can actually use that to help us derive two other versions of the cosine double angle formula. So this is currently our cosine double angle formula, but there are two others that exist. One way of doing this would be to swap out the cosine squared. What I'm going to do here is simply just rearrange this. So I have cosine squared of theta is 1 minus sine squared of theta. And then I'm going to substitute that into my cosine double angle formula. And then combine my like terms. So it'll end up being 1 minus 2 sine squared theta. That's one alternative to our double angle formula. The other alternative is I'm just going to rearrange again. And this time I'm going to rearrange this so I have my sine squared isolated. I'll rewrite it first. Sine squared theta will be equal to 1 minus cosine squared of theta, and I can substitute that into my formula. Instead of sine squared, so we'll have cos squared take away 1 minus cos squared theta. Distribute out the negative. It'll end up being minus 1 plus cos squared theta. And so now I have a 2 cos squared theta and then I'll take away 1. So these are two other versions of our double angle formula, specifically our cosine double angle formula. That might be a little bit easier to use depending on what you have available to you. Okay, we're going to do one quick example here because I think the formula is very straightforward. What's happening here, we have cosine squared, so we're asked to evaluate cosine squared of 5 pi by 12, take away sine squared of 5 pi by 12. This sure looks like a cosine double angle formula there, eh? We have cosine of 2 theta is cosine squared of theta minus sine squared of theta. Okay, and so the question, in this case, the theta is 5 pi over 12. So what this question is actually asking, I'll just rewrite it here. We can apply our double angle formula, and I could say, well, what's cos then? Cosine of 2, 5 pi over 12. I can simplify. I can simplify the 2 and the 12 to be then asking what is 5 pi? Ooh, that's pi. What's 5 pi over 6? Okay, we can simplify this. Let's draw our Cartesian grid. I'm going to roughly split this into sixths. Emphasis on roughly. 5 pi by 6. 1, 2, 3, 4, 5 lands us right here, with this being our terminal arm. And our related acute angle is pi over 6. And look at that. That is one of our special triangles. So we're going to use our special triangle here to solve. The other angle in that triangle is pi over 3, and the side across from pi over 3 has the square root on it. The hypotenuse is always 2, and then the opposite side is going to be 1. And so we double check now as well. Do any of these numbers need to be negative? Hypotenuse is always positive. The 1 is in the positive y-axis. However, the negative 3, or the root 3 is in the negative x-axis, so I do need to include a negative on it. Let's go ahead and solve. Cosine here would be adjacent, so negative root 3 divided by our hypotenuse, which is 2. So really easy to solve at the end of the day because we were able to apply that double angle formula. It's super straightforward as a formula, and I hope you find it just as easy.